This information is for people who are not fully familiar with the subject of free energy. What I mean by free energy is energy to run the devices which you use, that is television, computer, air conditioning, cooker, washing machine, fan and so on, without having to pay for fuel to generate that power. That sounds mad to people who do not realize that we live in an energy field so powerful that running every powered device on Earth for 1,000 years would never even be noticed by that energy field. Yet that is exactly the way that things are. There are air conditioning systems which can be bought easily and which can either heat or cool the air passing through them. These are heat pump systems which draw energy from the local environment as well as from the electrical supply which is used to make them operate. The efficiency range of these devices goes from 250% to around 500%. That is, the heating of the air is 2 to 5 times more efficient than using a fan heater or other electrical heater. One of them looks like this here. This is a Fujitsu KM air conditioner which attaches to the wall of your room. It's not particularly expensive. Now, the technical information supplied with these acceptable commercial units includes the fact that the output from this unit is more than 4 times the input power. That's called the coefficient of performance, or COP. And in this particular unit, the COP is over 4. They have it rated as 4.3 to 4.38 under typical conditions. Split air conditioning units, which have an outdoor section as well as an indoor section, are more efficient again, some having a coefficient of performance greater than 5. That is, the output power is more than 5 times greater than the input power which you have to supply to make it work. That's a fine performance, but it'll only work if you can provide the electricity which the air conditioner needs. Thanks to a lightning strike and the loss of 2 power stations a few days ago, more than 1 million people in the UK did not have a working electricity supply. It would be nice to have your own electricity supply. Free energy can provide that. There are 2 main groups of people who want free energy. The first group of people are those who don't want to pay for electricity, and the second group are the people who want to stop the pollution that the present oil-based system is causing. I'm sorry to tell you, but while the incoming energy which ends up as being your electrical supply is indeed free, obtaining a device to make the wanted conversion of the energy is itself by no means free. You can convert a gallon of petrol into a powerful trip of many miles, but to do that you would probably want to have a car, and cars are by no means free. So even if you have to pay for it, how do you get your own supply of electricity? You can definitely do it, and it can be done in several different ways, some of which are well beyond the abilities of the average person to arrange. The most simple way is using a battery with an ordinary DC to AC converter, which is called an inverter, to generate the same voltage and frequency as your local electricity supply. This battery and inverter system is a well-known method which has been used for many years, and very often the battery is recharged using solar panels mounted on a roof. This method has problems quite apart from the cost of buying and installing the solar panels. At the present time, which is August 2019, the most obvious choice for a battery is a deep cycle lead acid battery, which is roughly the same as that used in cars. However, most people are not aware of the practical difficulties with using a lead acid battery. The first problem is that a lead acid battery loses half the charging current which you feed into it. That means that for every watt of power that you draw from the battery, you have to feed back 2 watts of recharging power. Secondly, the next problem is that a battery of that type has a limited operational life. Typically, the battery can be charged and discharged 400 to 1000 times at the C20 rate of current draw, and if that rate of current draw is exceeded, then the lifetime of the battery is reduced. The C20 rate of discharge is 1/20th of the ampere rating of the battery. So for a 100 ampere battery, the battery life will be shortened if more than 5 amps is drawn from the battery. The third problem is that batteries do not recharge nearly as well if they are also supplying current. That is, a disconnected battery recharges very much better than one which is supplying a load with current. The fourth problem is that most people do not understand how little power can be drawn from a battery compared to the amount of electricity which they actually use from day to day. Take a 100 ampere battery, which costs £60 at this time. Its life will be shortened if more than 5 amps is drawn from it, and 5 amps at 12 volts is just 60 watts. That is, if properly treated, the 100 ampere battery cannot power a 100 watt light bulb. The fifth problem is the current draw from a 12 volt battery needed to produce 220 volt AC mains output is substantial, needing thick wires between the battery and the inverter. For a 1 kilowatt mains supply from a 12 volt battery running at 100% inverter efficiency would require a substantial continuous current. 1 amp gives 12 watts, so 1000 watts will require 1000 divided by 12, which is 83.33 amps. That's a substantial current. At 95 inverter efficiency, which is typical for the best inverters, that works out to be about 88 amps, and that needs an exceptionally thick wire to carry it. Many people want a good deal more than 1 kilowatt of electrical power. At the C20 rate of battery discharge, you are talking about 18 100 ampere batteries. To reduce the current draw from each battery, it's normal to connect 4 batteries in series to give 48 volts, and then use a 48 volt inverter. That cuts the individual battery current to 22 amps for each row of 4 batteries, and so for a C20 current draw you need 5 rows of 4 batteries with 4 batteries in each row, and that would be what's needed, and it would cost a total of £1,200. This looks like a serious list of problems, and yet solar panel battery charging systems can work well for many years. We can do better than those systems, as items 1 and 2 can be dealt with by switching from DC charging to DC pulsed charging, as that improves both battery life and battery performance. That can be done by having the solar panels charge up a battery, which is then used to drive a DC pulsing circuit which charges the main battery bank. The pulsing circuit can be built quite easily. Here is one from AlexCore of Russia. The document is available for free download, and it's chapter6.pdf, and the system is shown starting on page 35. This is the charging circuit shown here. It has one transistor. In this case, the transistor is a 2SC 3552 transistor, which has a massive specification. It can handle anything from 500 to 1100 volts. It can pass 12 amps continuously. It can dissipate 150 watts and is very fast acting. As to the power dissipation, you'll notice there's a metal plate as part of the transistor. That metal plate needs to be clamped to a heatsink if you're going to run large currents through this transistor continuously. The transistor itself operates very simply in a joule thief circuit. It operates on a coil which you wind yourself. The coil is air core, which means that it's just wound on an open former, something like the cardboard center roll of a roll of kitchen towels. It's made of two separate strands of wire, one shown in red, one shown in blue here in this diagram. There are 100 turns of wire of each of those wires, and they're wound side by side throughout. The two wires are first a red wire, then a blue wire, then a red wire, then a blue wire. And while that sounds complicated, it isn't really. You just wind the coil from two separate strands of wire, and the wire itself is about 0.5 millimeters in diameter. When the circuit is switched on first, the battery that's powering the oscillator itself has a current that flows through this blue winding and on through a resistor into the base of the transistor, which completes the circuit, and the transistor switches on very heavily. That creates a pulse passing through this red coil. That pulse will then fail because the induced power from the blue winding will fade away in time, and the coil will then switch off. Now the thing about a coil switching off is that it pulls the collector of this transistor up to a very high voltage until it exceeds the voltage of the battery bank that you're applying it to. This case it's a 48 volt battery bank of 4 batteries, and the voltage swings up above that and then feeds current into those 4 batteries and on through the driving battery to the emitter of the transistor itself. This is a very effective way of running a charger, and it will operate at hundreds of thousands of pulses per second. It's very effective. The arrangement is quite simple, and you can build it without needing to solder anything together if you want. This is your coil, though it's shown very small diameter here. It won't be, it will be about 1.5 inches in diameter, or maybe 40-45 millimeters in diameter for the former. But the arrangement is shown clearly here. You've got red, blue, red, blue, red, blue all the way through the coil, and then 2 of the wires are connected together. The end of one wire is connected to the start of the other wire, and this forms a bifilar coil, which is very useful and very effective. Designed by Tesla, it is one of the most effective coils around. But the arrangement here can be set up quite readily. If, as you're using plastic screw connectors from your local hardware shop to connect this circuit together, they come in several different sizes. If you don't get the smallest one, you may find that the transistor pins, which don't bend easily, are not the right spacing for these connectors. You get around that by bending up the central pin vertically up in the air and using one of these cut-off pieces to screw to that, and the wire from that then goes to, in this instance, this connector over here. This is the way that the pulsar is arranged, and the 48 volt inverter, which has a built-in on-off switch, is then connected across the 4 batteries. Generally when they're charging you have the inverter off, but that is not essential. You can actually charge the battery bank while the inverter is on, and the arrangement works out pretty well. These sketches shown here avoid any significant soldering, but if it seems confusing to you, then the electronics tutorial, which is shown at this link, might be helpful. If you want faster charging, the circuit can be expanded by creating additional sections, each with its own transistor. The charging coil is about 1.5 inches in diameter, that's about 40 millimeters, and wound with 100 turns of 2 strands of wire, each about 0.5 millimeter in diameter. That is, the coil is very simple to make, with just 200 turns of wire as shown in the sketch, and connected that way with the end of one wire attached to the start of the other wire. Quite apart from being easier to wind, that arrangement is a Tesla bifilar coil, which is more effective than a single coil of 200 turns. The circuit can be expanded to increase the rate of battery charge. You have, as before, your arrangement of driving battery, controlled charging resistor. For a 12 volt battery you are using a 1K resistor into the base of this transistor. 12 volts across 1K means that 12 milliamps flows through this particular resistor, or close to 12 milliamps. That means that the power rating of that resistor is going to be something like 12 volts at 12 milliamps, which is 144 milliwatts. That means that a 250 milliwatt resistor, which is a typical ordinary quarter watt resistor, would do perfectly well for that particular resistor there. I personally would recommend using a half amp resistor, which is something that's much more powerful than ever is going to be needed. The diode that feeds the pulse onwards is an ultra fast 5408 3 amp diode, and the capacitor that's put across the resistor to control the frequency is a 2700 picofarad, very small, very cheap, very light capacitor. That's the main basic circuit as shown before, but you can then add additional transistors on, taking the same signal from the blue coil and feeding it through the same resistor to the same transistor, using the same diode to feed on. You don't need the blue winding, you can just have a 100 turns of 0.5 millimeter wire to duplicate the red coil, and you can have up to 10 extra versions of those. It's more effective if each particular section has its own wire feeding to the battery bank. That is a more effective way of feeding a battery bank than just linking locally short lengths of wire to the built circuit. Anyway, go back to the solar panel problems. The obvious one that solar panels only work in daylight, and ideally in direct sunlight, that is at right angles to the panel. Also, solar panels differ a great deal in quality of performance. The last time I looked, Kyocera panels were the best, as they have extra cells which make the panel work well in poor light. Technically, it's not essential to use one or more solar panels. It's perfectly possible to have your DC pulsing charger charge your battery bank and another charging battery, and then you switch the charging batteries over every hour, one to drive the charging circuit and one to be recharged at the same time. Of course, it would be nice to avoid having to use batteries at all, and that is certainly possible. For example, you can use what's called a standard standby generator, and that can power the household equipment which you want to use. It might look like this, which is a fairly typical unit as such. Some people will say that's no use, it's too noisy and it needs fuel. Well, we can deal with both of those two problems. First, we can build a sound reducing enclosure for the generator, one which allows free flow of air to and from the generator. That can be made quite simply by using overlapping timber slats or planks covered in carpet. The air flows easily through the openings between the slats, but as sound travels in straight lines, it has to bounce off the carpet covered slats repeatedly, and each bounce absorbs part of the sound. So you mount the generator on a sound absorbing base and put one or two sound absorbing enclosures around it. The fuel? Well, you can make the generator operate on a gas mixture called HHO, which is generated from water using some of the electrical power from the generator. Also, you can add some cold water mist to the air entering the engine, and that converts into flash steam instantly on ignition and converts the engine into an internal combustion steam engine. That arrangement has been in use in remote areas for several years now. Details on how to do that can be found in the document via that link there, which is chapter 10 of the ebook on the Free Energy Info site. It can be done in two different ways. You can either adapt the engine to run directly on HHO, and methods for doing that are shown, or you can bubble the HHO through acetone and use an unmodified generator. The overall arrangement is as shown here. You have the generator, which creates both mains electricity and a 12-volt power supply. You run an electrolyzer off your 12-volt power supply, and you can make your own electrolyzer quite easily if you want to. That feeds gas through to the incoming air which is entering the motor, and you have a water jet arrangement called a Venturi tube, which feeds little droplets of water in along with the air into the motor. There's more detail, of course, on the document which is pointed to in the above link. People tend to concentrate on the items of household equipment with the largest current draw. While that's understandable, smaller systems can allow a better quality of life at quite low cost. One man who lives off the grid recently asked for advice as he wanted to watch TV in the evening without the noise of the generator running. That could be accomplished by making his generator charge a battery and then running the television from the battery using an inverter, while the generator is switched off and there's no noise. Alternatively, reducing the generator sound would be helpful anyway. A friend of mine in South Africa has been experiencing power cuts due to local electricity supply problems. There was no indication that the daily power cuts would end soon, so he arranged things to make life easier. He powered his Wi-Fi equipment from a small rotary generator which he designed and built. The generator is self-powered, and in spite of looking as if it is driven by a battery, it is in reality the battery is only used as a passive component which is there to act as a voltage level control for the inverter, stopping the generated voltage getting too high, that is. Generator puts out 150 watts of mains power continuously, and it needs no fuel to run. His particular generator looks like this. It's got a rotor created from a thick piece of plastic which has got magnets inserted in 5 places in it. Then there are 10 coils, small coils of wire around the outside, and they are connected together, and a Hall effect sensor is used to do the switching and sensing of the position of the rotor disc. So the arrangement both drives its own rotor and generates quite large amounts of electricity. The document for that is here, called rotarygen.pdf, again from the website. It's been suggested that instead of having a spinning rotor, it should be sufficient to pulse stationary coils with an oscillator circuit. Initial tests done by the South African developer indicate that doing that should be perfectly possible. But at this point in time, any such solid-state version of the rotary generator has not yet been built, tested, and proved to be viable. If it is confirmed, then it's a very attractive option, as quite apart from being motionless and quite easy to build, unlike the rotary version, which has limited space for coils around the rotor, the solid-state version has no such limitation, and so potentially could have any desired level of power output. The South African developer also constructed self-powering lights for various places around his house. The document describing that is shown via this link, and it has been found to be perfectly adequate for lighting when the local main supply has failed again. His particular choice of construction for these lamps looks like this. He has a circuit board there. You can't see it, but there is a small 12-volt battery involved in this, and the arrangement then drives an LED mains light bulb. It's very effective in his house. However, newcomers to the field of free energy devices often get confused by the options, along with the fact that many people think it's funny to show videos of fake free energy devices. Some, of course, are genuine. For example, Chas Campbell of Australia, who built a self-powered flywheel system which both powers itself and other equipment. He uses an ordinary mains electric motor and an ordinary electrical generator, and he has various shafts that are driven to change the rate of spin of the generator. The circuit that is involved in this is very straightforward. You have the motor, which is a 1 horsepower motor. It spins a pulley wheel, which is connected by a drive band to another pulley wheel, and that is continued up here, and a 10 kilogram heavy flywheel is spun by the system. That turns a 9-inch diameter pulley, driving a 4.5-inch diameter pulley, powering an alternating current generator. The output from the generator is fed back, and when the motor gets up to full speed, the switch is then flipped over and the mains is no longer used, and the motor is then powered by the generator, and the generator has excess output which can be used to drive other things. In Chas's instance, he prefers to drive the working equipment that he uses. That's electrical power tools, drills and the like. It is possible to find companies which offer to sell you a completed free energy generator. For example, the Infinity Sav company of South Korea, this is the link to their website, appears to be perfectly genuine, but then that's only an impression, as I've never had any kind of communication with them. Their main generator looks like this, which is an impressive looking piece of kit. There are other designs that are being continuously developed and tested to find high-powered free energy generator designs that work well. At the present time, there are several people working on a hydraulic design from Donny Watts. So far there are no reports of success, but then most of the builders are delayed by lack of finance or similar problems. The system is quite straightforward. There's a sump which contains a liquid, could be water. More generally, it's considered to use transmission fuel. A valve is opened and a 500 watt pump operates on a 3-inch diameter pipe, driving water into a drum which is set on bearings. The drum's got jets top and bottom, and that causes the drum to rotate inside the housing itself. The rotating drum then turns a pulley link to an AC generator, which gives you the power to drive equipment. This is a system which is over unity. In other words, the system itself, its output power depends on the diameter of the drum, and it also depends on how fast it is rotating. The faster it rotates, the greater the output power. That's why you need a valve in the intake, because if you don't turn it down, the drum is going to increase in speed so much that eventually it will actually tear itself apart, even though it's made of welded metal. Something will have to give. It's an exponential positive feedback system. If you treat it carefully, you can indeed get very substantial power from it. But at the moment, that's under testing and confirmation system. The normal thing is that drum should be typically at least a meter in diameter, and ideally more than a meter in diameter. That is more than a yard in diameter for our American friends. The problem that is common is that many people don't understand that when the designer states that a 3-inch or 75mm diameter pipe is needed, he actually means that. Instead, they think that a 1-inch 25mm diameter pipe will do, and it just won't do. It takes 10 1-inch pipes to match the capacity of one 3-inch diameter pipe. But people who try it will find that out the hard way, and generally they'll discover how to do it. That system is also available from the website. Another design which is of considerable recent interest involves changing the electronic drive to a 3-phase electric motor in order to get more than the usual amount of power from the motor, and then using that power to drive a standard electrical generator. While there's no guarantee that the system will work, a team of talented developers are busily investigating the design. The overall principle is to run a 12-volt 3-phase motor on 400 volts with an arrangement that is something like this. You have a battery that starts the system. That goes through an inverter to generate 220 volts AC. It goes through a transformer or other method to get up to 440 volts. That is then passed to a controller which feeds the 440 volts to the 3-phase motor, which drives the alternator, and then that is dropped down to give an output to a battery charger which produces 800 watts at 14 volts to feed the junction between the battery and the inverter. So the inverter, after the few seconds of startup, is actually powered by the alternator itself. There are various other designs which offer what appeals to most newcomers, namely silent, motionless operation and massively powerful output. And not only that, but the very much desired small physical size. Those sort of designs, typically as laid out by Don Smith, the one being shown here, it's relatively small. You can see his hand there. This is a small board. self-powered, and has enormously large number of kilowatts of output power. These designs do indeed work, but it takes an exceptionally skilled electronics expert to ever get one going. So please don't imagine that you can just assemble the stated, very expensive components in the arrangement described and expect it to burst into life. That is not going to happen, and a lot of very expert electronic tuning is needed, using unusually specialized equipment. So, to summarize, the actual situation, you can indeed have an energy system of your own, but if it is powerful enough to power all your household equipment, then it's likely to cost a significant amount of money to construct, even if that construction is done by yourself. Perhaps it would be better to call it low-cost electricity rather than free energy. If you decide to go ahead and build some project, then let me wish you every success with your project.